Welcome back to another YouTube Tuesday. My name is Derek, and today we're going to be going over a video from the channel iBoard Repair by Aaron Harrington, where he shows us how to diagnose and fix an issue with an iPhone 14 Pro that's got no image. Let's get into the video. Now, first and foremost, if there is a channel that you'd like to see featured, let me know in the comments below, or if there's a specific video that you think deserves more attention, comment it down below as well.
Hello, this is Aaron with iBoard Repair, and today I'll be working on an iPhone 14 Pro that was extremely smashed. It was run over by a car, so you can see a lot of damage on here. And the phone came to me without a screen. The screen was already removed, and the motherboard had already been worked on. So this went to another data recovery company or another board repair tech, and they were unable to solve the problem. And the phone appears not to turn on, but I believe it is actually turning on. I've done a little bit of diagnosis to this phone already, and let me show you why I think that. So here's the motherboard. It is the top layer of the iPhone 14 Pro here. So somebody's already split this away from the bottom layer, and they were working on this. And they did a lot of work to it already, and it wasn't necessarily the cleanest work. They dug around this screen connector here, so I do believe they came to the same conclusion as I, that this phone is turning on, but there's just no image on the device.
Man, yeah, definitely looks like someone's been in this device. Now, I'm sure he's going to go over it, but when working on a device, there's a couple things that you want to start with. One thing you'll come to recognize is what happens when you put power to the battery connector using a power supply. You'll be able to see the change in the power draw, and you'll be able to basically determine whether or not the device is booting properly or not based off of the pattern that it presents. And that way you can work your way back to the culprit. For example, right here, the first thing that I would do is I would test the pins and see what I get for diode readings on each one of the pins, and comparing it to a board view software like ZXW or JCID or JC Drawing, I mean. And going from there, diagnosing basically as far back as I need to before I find the issue. So let's see what he ends up finding, or how he goes about doing that.
I believe this is a no image case. They overheated the board a little bit, it appears to me, but it doesn't seem like it's too much of a problem. I don't like how they removed the shield because they were chipping the NAND here. But again, I think the NAND's probably fine. When I flipped this over, I did notice that this chip had already been reworked as well, and this is the image chip. I've gone ahead and removed this already since, but this was on the board when I first opened this up. I've removed it. So the first step I take when I'm working with a board that I don't know what's going on with is I take my DC power supply probes, and this is why I believe the phone is turning on, because of the sign that this will give me. I take my DC power supply probes, I touch them to the battery connector here, and I'll observe the amperage draw I get when I tell this phone to turn on by shorting the power button. I can short the power button right here, and we can see the amperage is giving what looks like a normal boot up sequence. So
you can see how up in the top corner it was popping up and down. It even went above 1 amp. When it does that, you know that it's pretty much booting. Now, if it just hangs down around 0.05, 0.1, but it never really gets up higher, it could be that there's another issue with the motherboard, and you'll have to kind of gauge what you find with experience as to know where to start looking, whether it's a short or an issue with something on the NAND. It's a whole slew of things that it could possibly be. But this phone looks like it's booting, so it's probably just an issue with one of the lines coming either off the connector or potentially between the display IC and the connector. So let's see what he ends up finding.
Doesn't look like it's turning off to me. It looks like it's staying on. And if I take my parts here and I plug them all in, this phone will still give me no image. So it doesn't look like it's doing anything, but according to my amperage draw, it is doing something. It's turning on. There's just nothing on the screen at all. It's not giving any image. So the first thing I did when I'm working with a device that is no image, I guess I'll show you the no image first, just so we can see a before and after. So if I take a good screen, battery, and charge port, The top board alone should turn on. It would give me a 3-minute reboot without being connected to the bottom board, but that's fine. We're just testing to see if it turns on at all. And this screen is also shattered, but this screen actually still works. I use it for testing all the time. But when I tell this phone to turn on, we're going to see nothing. And I just want to show you the before and after. But if I plug this in, I'll get a normal amperage draw from my amp meter down here. It's giving me 1.2 amps of charging, and this is doing nothing. And that's to be expected. That image chip is already gone, but even before that image chip was gone, this phone was still giving me no image. And I do believe I figured out why, but first I want to tell you the steps I take when I'm dealing with no image. I'll do this basically every time. So basically what I've shown right now is what I do every time I'm working with a device. Is I'll take my DC power supply probes and I'll look at my amperage draw, and then that amperage draw will tell me what I'm going to be doing next. And in this case, what I did next was I went ahead and I tested the diode mode values of every single one of these pins here. And we can look at my multimeter here. It's in diode mode. And I went ahead and tested every single one of these pins here. And every single one of them gave me what looked like a normal reading. So that can throw you off a little bit. A lot of people think that if they have no image, then they must have a sign from their image connector here. And that is what the last tech kind of came to the conclusion of as well. You can tell because they removed all of the underfill away from all of these components, hoping to find something, but they didn't find anything. If we open our board view software on the iPhone 14 Pro Max, this is the connector, and when we zoom in, it will give us all of the values here. So OL, 0.45, this is ground, OL. I checked every one of these, and every one of them gave me the correct value. The next thing I checked was the image chip. And this is the image chip here. And like I said, this had already...
So if you get all of the values perfectly correct on the connector, the next thing that I would do, and I think he's probably going to do it, which is check the values under the display IC. If he finds that this display IC, if any of the pads under it have a misreading, maybe they just read open line when they're supposed to be a data line or a ground line, that could definitely point him in the right direction. So it kind of helps you see the thought process behind this type of repair, starting because you have no display with the display connector and then making your way backwards to hopefully the culprit.
Already been replaced, so I just went ahead and removed it because I tend to just not trust the work of others. I don't know what they did. But if we zoom in here, we can also see this also gives us diode mode values. So before I went ahead and tried to replace this chip, I decided it's probably a smart idea just to check every single one of these values as well. Because if anything's missing under here, then the chip will not work. If the chip does not work, that is the image chip, then the image will also not work on the screen. So that's the next thing I decided to check. And I was checking everything, and everything was appearing correct until we got down to here. These are just ground pads. That's what the 0.000 means. It's not ground like this because it's not directly connected to the rest of ground. And I noticed there's another one over here. This one did give me the ground reading. This one did not give me the ground reading. And if we look at...
So this is why it's important to have board view software. So you can actually see, okay, this is ground, but it's not necessarily ground in the way that is straight to ground. This is connected through a circuit to ground. And if you're reading open line, you definitely need to figure out why. And using the board view software, it's really quite simple because it allows you to simply click and see what it correlates to. That way you can find the component much easier than having to basically guess and check. Now, if you don't have if you do have the board view software, but it doesn't give you the values under the chip that you are trying to test, you can always take a donor board and get the values off of it, given that it's a good donor board, of course, but you should be able to get the values that you should be reading off of it and compare it to what you're getting on the device you're working on. Obviously, that is a longer process because you have to record all of the values and then go and cross-reference them, but it definitely can get you out of a pinch.
Look at what these lines are. These lines go through some big coils and they connect to ground on the other side. And like I said, that line was connecting to ground. This line was giving me an OL reading like this, which is basically not connected to anything. So this line is connected to this big coil. If I'm not getting the ground reading, that means that that line is not going through this coil and reaching ground. And that means that this coil is not connected fully. And that's where I'm at right now. I believe that I have a bad coil right here, or that if I push it really hard, it's going to fall right off. So that's where I'm at. And that's kind of the basic way you'll always want to check like a no image problem or any type of problem that's like isolated to one circuit. So I did see that he removed the shield here, and it kind of almost made me think that maybe he had came to that same conclusion, but I don't really think so because it doesn't really look like this area had been worked on.
Typically when you're looking for these big coils, it's obvious they'll be literally loose. You just touch them and they fall off, or they're completely shifted out of place. What'll happen is the legs that hold them down will basically break away, and you'll lose that connection, that bridge between one big pad and the other. And so if he nudges it, it should just, I mean, not every case, but it should move if he just touches it with the tweezers. The other thing it could potentially be is the trace between the coil and the display IC could be damaged within the motherboard somehow, but that's not as likely as it just being the coil.
This flux is just left over from when they were working in this area. And I'll show you the readings that I got. So this one should be ground, and I'm getting that OL reading, the open loop. And this is the other one that's connected to that coil, to the other coil I mean, and this one is giving me the ground reading. So this line is connected to this coil, and this line is connected to this one. So let's give it a push and see if it falls off. Pretty interesting. It's not loose. So for whatever reason, this coil just lost continuity across it. So I still believe once I pull this off and replace it, I should most likely be fine. I guess there is also the possibility that somehow the trace that connects this line to this coil is broken, because I kind of expected this would push off. And you know, this phone had taken such a large impact. You can see how shattered it is. It's possible that there's like damage in the layers itself. But one step at a time, I'll just go ahead and replace this first. And this should be a fairly short video, but it's always it's a good idea for you to know how to diagnose simple problems like no image. And in this case, it was as simple as making sure to check all the diode mode values that are available to us on ZXW. If you didn't have ZXW, you can always just take a donor board and compare readings to the donor as well. And that's another method I'll use if we don't have readings under or on a certain board. I'm quite surprised at how firmly this was attached. Oh no, there it goes. It was disconnected. So there we go. This was a broken coil here.
You can see it's completely missing the pad on the bottom of the coil. Basically, that top side should look like the bottom side. These coils are kind of difficult to remove because they do require a lot of heat, and you're working right next to the NAND, and you overheat that, and you've got issues because of the underfill. So you got to be careful with your temperature, airflow. You have to know what you're doing. He's obviously not shielding anything, which really only comes with the ability to, with experience. He knows how much he can apply and get away with without having to do all the extra work to shield stuff. So yeah, it looks like this probably is all he needs to do is replace the coil in order to fix it. But he's going to also need to clear the broken pad off of the big pad, which is kind of hard because of the size. It also being ground plane, meaning the thermal mass is much larger, requiring more heat, maybe a bigger soldering iron tip. But let's see how he goes about this.
So this should be pretty easy. Like I said, once this gets on here, this board should boot right up, and well, it's already booting, but it should give me image back. I might need a bigger iron to get this pad off, but let's see if I can get it off with this.
Looks like the board was moving there, so he's getting out of jig. It also, those pads tend to break up, and so you got to make sure you remove all of it. Otherwise, you're going to have an uneven surface when you go to solder on the new coil.
I will still also have to replace that chip, and that will be the last step after this is replaced. And data recovery or board work in general can be very difficult if you don't know what you're doing, or it could be very fast and straightforward if you have a good idea of what you're looking for. Like, for all I know, the technician spent hours working on this device and just was not able to solve it. And it's very common to go down a rabbit hole and just not be able to figure it out. So that's good enough. It's not perfect, but it will take a new coil just fine. And I have a donor board right here. So I'll just take the coil directly from here. This one already has a lot of, it's already been harvested and had a lot of work. So I have a lot of donor boards. It's always a good idea to just stock up on them. You can find them cheap if you look in the right spots.
You can see that it was able to basically just pop it away with some wire cutters. It did tear up a little bit of the ground plane, but obviously this board, and it looks like he knocked off a little cap here. But obviously this is a donor board, so he wasn't really too concerned about damaging it at all. But it looks like those coils are intact, so he'll be able to snag one of them. So as you can see, he checked to make sure it had both sides. Sometimes these coils like to fall apart when you remove them, and so the leg might have stayed behind. So he double checked that it was still like that. I also like Aaron's videos because he does show up in the corner the temperature. He literally has the multimeter, the rework station, and the power supply all up in the top corner, which is convenient for the viewer to know exactly what he's using while he's doing his repair. So let's see what happens when he installs this coil. Now, obviously, he could have gone to the extent of wicking away all of the factory solder and the additional solder he added to add fresh solder to give you a cleaner result. But he's going for data recovery here, not long-term functionality, so it's totally fine to go about it that way. But overall, I really enjoy the way he puts his videos together. I think it's easy to take advantage of this type of content. Even though a lot of his videos are longer, they definitely are worth the watch if you're looking to get into this type of repair.
That should be all it needs, and we can verify it's on there good by checking the diode mode value underneath that IC again, or on those pads. So now if I take my multimeter probes, I should no longer have OL on those on that line. I should now have what looks like ground. And there we go, we got a ground reading. That's what I was looking for. And this is the chip that was on there, and I could reball it, but it looks a little bit damaged to me. Does it? Maybe not so much. Right here, there's just the tiniest chips on the corner. It's not very much, but I'll just replace it either way. I'll just take this chip here, and I'll try to do a clean pull because I don't really feel like reballing this. If I could pull it clean, then I can just set it back down without doing a...
Okay, a couple things. This chip is kind of a hard one to do a clean pull on, just because of how close it is to all of the components around it. And what he means by a clean pull is he wants to lift the chip up straight up, so that it doesn't slide around or tilt in any direction, because what happens is the solder, as it's liquefying, it'll basically spread and join up with its neighboring solder, creating a difference in the amount of solder that's left on all the pads. But if you have a clean pull, very similar to the way that I like to do a clean pull on the sandwich layer of the iPhones, if you can get a clean pull, then you don't have to reball the midframe when you go to solder that back together. Same kind of goes for chips, IC chips. So obviously, the bigger the chip, the more pads you have, the riskier it is not to reball. And this is a chip that I would personally probably reball. I wouldn't go for the clean pull installation. So let's see if he does that, and if he does it, I'll tell you a little bit more about why not.
I'm recording 2 videos today. I haven't been making very many videos lately, so I'm trying to get more recorded. So if I release another video close to this one, I have a bunch recorded, but depending on which order I edit and release them, you may see me in the same shirt in another video very soon. I know that doesn't really matter to anyone, but it will be a little bit hard to get a clean pull on this because I don't really have a gray area that I can put my tweezers. I'll just kind of overheat the board a bit and maybe I'll get lucky, but I might have to reball this.
One thing you could do, just because this is a donor board, is you can move components out of the way to give yourself a better grip. You could pop off that big coil and the cap if you wanted to go for a vertical grip, or you can pop off some of the little resistors or capacitors along the border, and that'll give you a good space to put the tweezers so that you can get a better grip on it. In general, even if you're not trying to go for a clean pull, but you're just trying to get it off, that definitely helps to clear up space if it is in fact a donor board and you can do without them. So
I think I'll just remove some of these chips, or maybe now I'll be able to get a clean pull on here a little easier. I might still mess it up. It's sometimes hard to do. I moved it a little bit more than I wanted, but I do believe the balls are all going to be intact still. Yeah, that looks...
Yeah, you can see there's a good amount of uniformity there. I don't see anything that's bigger or smaller by the, even under a microscope. If he zooms in a little bit more, maybe you could tell if there's a difference, but on the board and on the chip, it all looks the same. So he could probably get away with this. Now, the other issue, we'll see if he goes about this, is whether or not you wick the pads on the board that you're transferring this to, because if there is a pad that has more solder, it could create a high point, preventing the chip from sitting down properly and all the joints making contact. So that's why I like to wick all the pads and reball the new chip, etc. So we'll see if he goes about that. We can also gauge by looking at the board whether or not he has a roughly even solder. The other thing that makes this difficult is when you're soldering on a chip that has solder balls on it and you haven't fully wicked the pads below, instead of the balls resting on a flat surface and not like wanting to move anywhere, it's like trying to balance a ball on a ball. It'll want to roll off all of the time. And so it's really hard to get a chip that has some solder on it to stick to or align itself properly or keep itself aligned when you got it in the right spot without holding it in place if there is solder on the board, because it'll tend to want to fall off the ends of the solder. So let's see what he does. And we're almost to the end of this video.
Fine to me. I should be able to reuse it still without having to reball. And now once this chip is on here, we can test with our parts again, and hopefully we'll see an Apple logo.
So it's kind of hard to tell, but it looks like when he took the chip off, he might have gone over it with the soldering iron to kind of even out all of the solder pads so that he could test with the multimeter. And that's why they kind of look a little off as well, is because he was probably probing into each one of them. And when you probe with the metal tip into the soft solder, it creates little divots, causing it to look off. So I think that he has a relatively uniform solder across the motherboard. So this should go on, but he's probably going to have to hold the chip in place with tweezers while he solders it down instead of aligning it and letting it snap into place. It might be able to snap by itself, but we'll see how it goes. Definitely a way to do it, definitely not the way I would do it, because I like to reball things when I can.
It's a tiny bit crooked, but it should twitch into place when the solder melts. There we go. Looks like it moved into place, and we should be able to see an Apple logo now. So I'll grab my parts and let's see if it's turning on. Like I said before, the top board alone will boot up, but it will give us a 3-minute reboot. So we'll turn off every 3 minutes if it's not connected to the bottom board. But as long as it's turning on, I know this phone's going to be good to go. And as long as I don't run into any problems when I'm taking data, then this will be the end of the video once I confirm this. If I do run into like a 3-minute reboot from an unexpected problem, I'll turn the recording back on and address that, but I don't expect I will. And there we go, Apple logo. I can verify touch is working as well, I suppose. And we'll also boot to the swipe up to upgrade screen if it's not connected to the bottom board because it can't communicate with the NFC chip. So that's all normal. It'll freeze here for a second before it goes there. There you go, swipe to recover. So if you were to swipe to recover, you can try to bypass the NFC problem, but it wouldn't work in this case because this will reboot in 3 minutes, which is not enough time for it to go through that next screen. So either way, this phone is going to be successful. I'll be able to recover data from it. I just need to put it into a jig with a good bottom board. And there are a few other things that could happen, like it could reject the passcode if I were to use a mismatched bottom board, so the non-native bottom board, and I don't move over the NFC chip. It does that sometimes, but it doesn't do that all the time. So most of the time, I will attempt to use a mismatched bottom board, especially because, in this case, I'll probably just try to use this one. It's not too damaged, so I can probably avoid that. But if I was missing too many pads, I would try to use a mismatched bottom board. I think in this case it will be fine to use the native bottom board. But yeah, that's how you would diagnose a no image problem on an iPhone 14 Pro Max. You check the connector first. If the connector looks good, you check the IC. If replacing the IC doesn't work, in an ideal situation, you'll want to have checked the diode mode values underneath the IC before you replace it. That way, that's what I did. I was able to see that there is a bad line underneath that IC before I went ahead and just tried to replace it. If I would have done that, it wouldn't have worked, and I may have been even more confused, and I would have had to do more work of taking off that IC again and trying to replace it again. So, customer will be very happy that they'll have access to their data. So thanks for watching this video. Hope you learned something. Hope you stop by again.
All right. So what he meant by a jig. All right. So what he meant by a jig is basically something like an eye socket. Basically a jig that helps connect the top board to the bottom board without actually having to solder it with these little spring-loaded gold pins that makes contact with all of the pads around the perimeter of the sandwich board. And you compress them together, and it'll act as if they are soldered, so that you don't have to go through that process of doing the solder work, but you can still recover the data. So great tool to have. I highly recommend you go take a look at the rest of his videos, especially if this area of the repair industry is something you're wanting to get into. Also, if there is a video that you've watched or a channel that you frequently watch that I haven't mentioned before, leave it in the comments below. I'd be happy to take a look at it and make another YouTube Tuesday video out of it in the weeks or months to come. Thanks a ton for watching. We'll see you in the next video.